Good afternoon, class. Today we're going to be looking at 8.5, adding and subtracting complex fractions, continuing on from what you just learned in 8.4 with the multiplying and dividing complex fractions. So today is going to be similar, but it's going to have a little twist on it because now we're adding and subtracting versus multiplying and dividing. Now, when adding and subtracting, we talked about this yesterday a little bit, what's the key thing that you have to remember? Multiplying and dividing, this is not true, but adding and subtracting, you have to have a common denominator. Okay, so that's what's going to make today just a little bit harder than what you did yesterday. You have to have that common denominator before you can combine them. Now, little review. We're not going to review that multiplication division down there. We did that the other day, but we are going to review this addition and subtraction up at the top. Okay, what did we just say? I cannot add these. Why? Because there's a 3 and a 6 as my denominators, and I cannot add them unless they are the same. Now, the ones that we're going to be doing in a minute with polynomials will be a little bit different, but the concept stays the same. The denominators have to match. So I have a 3 and I have a 6. How do I make these match? By turning the 3 into a 6. Well, how do I do that? How do I turn 3 into a 6? I have to multiply it by 2. 2 times 3 is 6. Okay, but don't forget, if we're changing this fraction, the whole goal is to change this first fraction. If I'm changing this fraction, so I have a 6 on the bottom, I have to also manipulate the top. So if I multiply the bottom by 2 to get it to a 6, I also have to multiply the top by 2. So that fraction is now 4 over 6. Now, remember, these are the same thing. 2 over 3 is 4 over 6. Those are the exact same thing. All we're doing is manipulating. Okay, and why are we manipulating it? So that the denominators are the same. And then once the denominators are the same, the 6 just stays 6, and we're adding the top. So 4 plus 1 is 5. So our answer would be 5 over 6. Now, the next one's the same, except it's subtraction. So I have to have common denominators. So what did we say? How does this 3 turn into a 6? We have to multiply it by 2. So therefore, we have to do the same thing on the top. I'm coming up with a fraction that's going to be the exact same thing as what I have. So 2/3 is the same thing as 4/6. Now, this time, the concept stays the same. This denominator stays a 6. So we're going to have a 6 in our answer in the denominator, and the top is what we're actually subtracting, 4 minus 1. 4 minus 1 is 3. That's not our final answer, though, because we can reduce. We always need to remember to look to see to reduce. 3 over 6 is 1 over 2. So yesterday we did the multiplication and we did the division. And if you don't remember that, you can go back and look through your notes, try to remember what we talked about. But with multiplication and division, you don't have to have a common denominator. You multiply them across. But with addition and subtraction, you do. The denominators have to be the same. So let's look at our first example. First thing you need to recognize is this addition. Since it's addition, the denominators have to be the same. Well, I'm starting you off with an easy one. The denominators are the same. So I don't have to do anything. I can add these. First question, what's my denominator and my answer going to be? Go back to what we just did a second ago. Does the denominator actually change? No, so the denominator in my answer is 3x. I'm adding the top. The denominator in the bottom stays. So the top will be 2y plus y, which is 3y. The bottom stays 3x. Then remember again, simplify if you can. As always, I've got a 3 over 3, which cancels. So my answer is just y over x. My next one, again, starting you off basic. I have an addition sign. First thing to recognize. And then second thing, denominators are the same, so I don't need to do anything. So the denominator in my answer is going to be x minus 4. We're adding the top, 3x plus 6. Can I actually add these? One of them has an x, one of them is just a constant. Can I actually add these? They're different. They're not like. So it just stays 3x plus 6. Now, if you stop right here, you are pretty close. Okay, but I said always make sure you simplify, and simplify means taking out common factors if you have them. So when I look at the top, I've got a 3 and a 6, so this can technically still be simplified. 3 and 6 can be simplified by taking out what number? A 3. So when you take out that 3, this is now x plus 2. Now remember, simplifying from here, just like we did yesterday, we have to have things that are common. I've got an x plus 2 on top, x minus 4 on the bottom. Nothing we can cancel or simplify there, so that is our answer. Next one. Looks a lot longer, and it's going to take a couple more steps, but it's not really much harder. I have an addition sign, but my denominators are the same. So I can go ahead and combine these. My denominators are the same, so it's going to stay the same, n squared plus 8n plus 16. And remember, we're adding the top. So what am I going to get when I add my top? Do I have anything to add n squared to? Nope, so it's still n squared. I have a negative 6n plus 4n, so that's going to give me negative 2n, and then minus 24. Now, this is where you got to make sure you keep going. Don't stop. Remember, simplify as much as you can. So this is what I have. And then what does simplify mean for this question? I've got n squareds, n's, and numbers. So simplified for this question means factor. I have to factor these to see if I can simplify them. So 3 terms, what did we say yesterday? If there's 3 terms, this is guess and check. What multiplies to 24 and adds to negative 2? So 24 times 1, 12 times 2, 8 times 3, 6 times 4. What gives me 2 when I add them? Nope, nope, nope. 6 and 4. What kind of a 6 to get this negative 2? It's going to have to be a negative 6 and a positive 4. Same thing on the bottom. Multiplies to 16, 16 times 1, 8 times 2, 4 times 4. How am I going to get this plus 8 right here? 16 and 1 doesn't give me 8. 8 and 2 doesn't give me 8. 4 and 4. And how do I get a plus 16 and a plus 8? 4 and 4. Now that I factored them, do what we did yesterday. Can I simplify this? Do I have something on the top and something on the bottom that can cancel? N plus 4 over n plus 4. So my answer is n minus 6 over n plus 4. And again, from yesterday, can I cancel these n's? No, because the n goes with the 6 and the n goes with the 4. Those are factors. They are paired together, so you can't start canceling one part of it. Okay, so make sure you take a key note for that from yesterday. Okay, a couple more. Next one. Now, here's the first one where we're going to have to start figuring out our denominators. They're not the same. So, over here, what do I have? I have 5, and how many x's? 2. That's what that x squared is. Over here, I have a 3 and an x. So we need to figure out our common denominator. Okay, we'll start with your numbers. What can my common denominator be if I have a 5 and a 3? 5 and 3 can both become 15. So the 5 and 3, the common denominator for that would be 15. Now, same concept for my x's. I have 2 x's and I have 1 x. You can never go down. Remember, you're talking about common. The 5 and the 3 have to go up to become 15. So I have 2 x's and 1 x. So when I'm talking about common, I'm going to have 2 x's. So this one isn't going to have to change, but on this side, I'm going to have to add that second x to it. Okay, so this is how we're going to have to manipulate. So our common denominator is 15x squared. That's step 1, and for a lot of you, this is going to be the hardest step. So maybe checking with me or your neighbor when you're working on your homework to make sure you got that step right before you do the rest of the question will be a good idea for you. So 15x squared is my common denominator. Now, your second goal is how do I turn these into the common denominator? Because remember, I can't actually add until I have the same thing on the bottom. So how do I get 5x squared to turn into 15x squared? Well, the x squareds are already taken care of. So I just have to decide, how do I get 5 into 15? Well, how do I get 5 into 15? Multiply by 3. But what did we say a second ago? If I multiply, because I'm manipulating, So if I multiply the bottom by 3, I also have to multiply the top by 3. Okay, we're manipulating these fractions. So whatever you do on the bottom, you have to do on the top. So we're going to multiply both of them by 3 to get that 15x squared. Same thing on this side. How do I get 3x squared to turn into 15x squared, that common denominator? I have to multiply 3 by 5. I have 1x and I need 2, so I have to multiply x by x. So in order to turn this into what I need, I have to multiply top and bottom by 5x. Like I said, that's going to be the hardest part for some of you, okay? So make sure you really take your time on that part. So figure out what we have now. We have 21 over 15x squared. 8 times 5x is 40x over 15x squared. Now that they're the same, I can actually combine them, and this is addition, so we need to add 21 plus 40x. Are these like? Can I actually combine them? That one has an x, that one's a constant? Nope. So we can't combine them, we're just going to write them down. And then what's going to be on their bottom? 15x squared. So 40x plus 21 over 15x squared. And the only way I could simplify this question would be if I could take the same thing out of all of these numbers. Remember, we've talked about that before. I can't just do 40 and 15 or 21 and 15. If I could simplify all 3 of them, then you could try to take something out. Okay, but for this question, we can't do that, so this is our answer. The next one, common denominator. What do I have right here? I have a 5. I'm going to write this on the side. I have a 5 and an x. And what do I have over here? I have a 5 and an x minus 2. And remember, the parentheses are a big part of these. The x and the 2 go together. So what can I change these two into to make them common? Well, the number's easy. I have a 5 and a 5, so that's already common. So 5 is going to be in my denominator. I have an x and an x minus 2. Okay, if it helps some of you a little bit, this is like an x plus 0. So this x plus 0 is different from this x plus 2, or I'm sorry, x minus 2. So you cannot manipulate that. Those are two different things. So when I'm talking about my common denominator, remember I have to incorporate everything. So I'm going to need an x and I'm going to need an x minus 2. So my common denominator is that 5, the x, and the x minus 2. Now, just like we did on number 4, now we have to decide what's missing from each part. So in this first part, how do I get to here? I already have my 5, I already have my x, so it's the only piece that I'm missing. I'm missing the x minus 2. So that's what I'm multiplying the top and the bottom by, the part that you're missing, x minus 2. Over here, I have the 5, and I have the x minus 2, but what am I missing? I'm missing the x. So multiplying the top and the bottom by x. Okay, now we actually multiply and see what we get. So on the bottom, we're just going to leave them just like they are. So my bottoms are going to look like 5x, x minus 2. So don't multiply your bottoms through. Do not FOIL these. Leave them just like that. The top, however, you need to FOIL, or distribute, depending on what kind of question it is. Okay, but you need to pull that 4 inside here and distribute this out. So what is this going to become? This is going to become 4x minus 8. Now, same thing on this side. I need to take this x plus 8, and again, if it helps you to put parentheses around it, do so. I need to multiply x times x and 8 times x. So that's going to give me x squared plus 8x. Now, the next step, most of you probably won't need to write once you get the concept of what we're doing, but I'm going to show it just to make sure everyone understands. My denominators are the same, so I can combine these, but a big mistake that you're going to make is this is minus x squared plus 8. Okay, and remember, if you got to draw these parentheses, do so. So if I put parentheses here, I'm subtracting this entire binomial. So if I'm subtracting this entire binomial, the x squared is being subtracted and the 8x. So this 8x is no longer positive. This 8x is now negative. It's a negative x squared minus 8x. Okay, so be careful with those negatives. In the first couple, they've been positives, okay? But be careful with those negatives. It's got to foil through. It's got to distribute through. Now, I distributed it through. Now I can combine what I have. So I've got a negative x squared. I got a 4x and a negative 8x, which is negative 4x minus 8. You could take a negative 1 out. You don't necessarily need to do so. You need to factor if you can, but when I look to factor this question, 8 times 1 and 4 times 2 are my options. Neither one of those gives me my 4 in the middle that I need. Okay, so it cannot be factored. That's why that is my answer. Okay, the next one, common denominator. Now, first thing you should recognize with this one, before I come and get my common denominator, I'm going to have to factor this right here. Okay, make it easier on yourself. Factor this out first. So 15 is 15 times 1 or 5 times 3. How do I get a plus 2 and a minus 15? Positive 5 and negative 3. So step 1, factor. Now, hopefully some of you recognize I did something else at the same time. I factored on the right-hand side, but on the left-hand side, I simplified as well. Okay, because again, in order to find my common denominator, I need to make sure I'm making this as simplified as possible. So I took my 4n minus 12 and I took out a 4. So I have 4, and this is now n minus 3. Okay, this is going to help me tremendously when I go to look for my common denominator. Okay, again, common means I have to include everything. So let's look at my numbers first. I have a 4, and there's nothing here, so what is it? I have a 1. So my common denominator is going to be this 4. I have an n minus 3 and an n minus 3, so n minus 3 has to be a part of it. And then there's nothing else over here, but what else needs to be in my denominator? This n plus 5. So my denominator is going to be 4, the n minus 3, and the n plus 5. Okay, again, what's our next step? We need to make them turn into that. The denominators need to turn into that. So this one already has the 4 and it already has the n minus 3. What is this one missing? It's missing the n plus 5. This one already has the n plus 5 and the n minus 3. It's missing the 4. So multiplying top and bottom by what you're missing. Okay, again, the denominators are going to stay like this. Do not foil the bottoms. You're going to make a lot more work than what you need. Leave them just like this. The top you need to distribute. So on the top, 3n plus 15. And then over here, what are we going to get? We're going to get, remember these go together, so you got to distribute this, 20 minus 8n. Now, some of you already see the subtraction sign, but notice I haven't done anything with it yet. All I did was distribute. I did that first. Now I'm going to deal with the subtraction sign. So now I'm going to pull this subtraction sign in. Again, if you need parentheses, put them there, because the subtraction sign goes to the 20, so it's a minus 20, and to the negative 8n. So is this a negative 8n still? Nope, this is now a positive 8n. And our denominators were the same, so we just combined them, 4n plus 5 and n minus 3. Now, combining, I got a 3n and an 8n, gives me 11n. 15 minus 20 is negative 5. Can I take anything out of 11 and 5? No. Is there anything on the top that can cancel with the bottom? No. So that is your answer. Okay, 2 more. Hopefully they're getting a little bit easier for you. Now, first thing, factors before we can find our common denominator. So over on this side, what multiplies to 9 and adds to 6? 3 times 3. This one here, there's nothing in the middle, so technically it's a 0x. Okay, so if it helps you guys to think of it that way, what multiplies to 9 and adds to 0? 3 and 3. But how do they add to 0? One of them has to be positive, one of them has to be negative. So that's our perfect squares, x minus 3 and x plus 3. That's how we get that x squared minus 9. The 0 cancels with a plus 3 and a minus 3. Then this one over here, to be a plus 6 plus 9, has to be a positive 3, positive 3. Okay, so our denominator. How many x plus 3's do I need on the bottom to make these the same? This one has 1, this one has 2. So how many do I need? I need 2. So I need 2x plus 3's. And then what else do I need in order to incorporate everything? An x minus 3. So my common denominator is x plus 3, x plus 3, x minus 3. Okay, how do we get there? What are we missing? In the first one, we have the x plus 3's, we're missing the x minus 3. In the second one, we have one of each, so we're missing that second x plus 3. Okay, again, do not start distributing the bottom. Leave it just like this. Distribute the top. So on the top, I got a FOIL. So x squared, negative 3x, x, and negative 3. Over here, distribute negative x minus 3. Now our bottoms are the same. Since we multiplied by what we were missing, our bottoms are the same, so now we need to add our tops. Okay, it's addition, so I don't need to worry about changing my signs or anything like that. Just add, combine. So I've got x squared. I've got negative 3x, positive x, negative x. So negative 3 plus 1 minus 1 leaves me with negative 3. And negative 3 minus 3 leaves me with negative 6. So we have x squared minus 3x minus 6. Okay, again, if you can factor, always factor. But what multiplies to 6? 6 times 1 and 2 times 3. Will either one of those give me this 3 right here? No. So you cannot factor, so you're done. Last one. Okay, what do we have? Over here on the left, what does that mean? I've got a 3 and how many x's? 3. Right here, what do I have? I've got a 6, a 3, 3 x's, 2 x's, but I got a plus sign in here. Okay, so before I can truly figure out what my denominator is, I'm going to have to simplify. There's a plus sign right here, so I need to decide, can I factor? Can I take something out? What can I do? I've got a 6 and I've got a 3. I can take out a 3. I've got an x cubed and an x squared, so I can take out an x squared. The biggest mistake I see on these, though, when people take out 3x squared, you guys get that there's 2x left right here. But when I take a 3x squared out of a 3x squared, the 3's cancel, the x squareds cancel. But remember, be careful with that word cancel. When I take 3x squared out of 3x squared, they cancel. But what is the same thing on top and same thing on bottom? When you divide those, it turns into a 1. If you don't have a 1 here, you'd mess up the entire question. 3x squared divided by 3x squared is 1. Now, since we simplified this, we can figure out what our common denominator is. Okay, well, we already said the first one. It's 3 and 3 x's. So what do I have over here? I have a 3. That x squared tells me I have 2 x's. And then I also have a 2x plus 1. So my common denominator has several parts to this. I've got a 3 in both of them. Well, that one's easy. I need a 3. I have 3 x's and 2 x's. So what's my common? I have to have more. So my common's going to be the 3 x's. And then I also have to include that 2x plus 1. So that's what's going to be common between the two of them. So what do I need? The first one has the 3 and the 3 x's. It's only missing the 2x plus 1. The second one has the 3. It has the 2x plus 1. It only has 2 x's, and we need how many? 3. So this one's missing 1 more x. Again, leave the bottom just like this. Do not start to distribute. FOIL the top. Distribute the top. 8x plus 4. X times x is x squared. Bottom's the same, so now I can combine these. And it's just addition, so I don't have to worry about negative signs. So what do I have? X squared plus 8x plus 4. Again, can we factor this? 4 is 4 times 1 or 2 times 2. Will that ever give me 8? Nope. So you can't factor, so you are done. So I hope you enjoyed the lesson today. Again, I know it was a little bit longer, but you guys don't like addition and subtraction, finding those common denominators. So I want to make sure that I took time explaining that. Remember, if you think you're going to have trouble with this denominator part, figure that out. Make sure you're right before you solve the rest of the question. Now, last part. Oh, I'm not solving. I just want to make sure we can find the common denominator. I've got a 2 and I've got a 4. 2 can become 4, so 4 would be the part of my denominator. I have an x. Do I have any more solo x's? Nope, so I need an x. I have an x plus 3 that I have to take into account. That takes care of this one over here. I have an x minus 3 that I need to take into account. That takes care of this one over here. So my common denominator would be a 4, an x plus 3, and an x minus 3. Okay, so if you have 3 terms, you've got to make sure that you accommodate all 3 of them. So the first one, I'd be missing everything but the x plus 3, so I'd have to multiply by 4x and x minus 3. The second one, I need the 2 to become a 4, so it would be multiplied by 2. I've got the x minus 3, so I'd multiply by x plus 3. The last one, I have everything except for that x, so the only thing I'd be multiplying by is the x. So again, I hope you enjoyed the lesson. Here's your homework. I'll see you guys tomorrow.